Okay, let's get started with day 2. I haven't looked at it yet. Simple template, same as every day. Little method that reads the input that we're gonna get and an empty main. Let's go. All right. So what is a toboggan? It's a French word. Oh, it's okay. That's funny. A toboggan is what we would call a sledge. That's a slide in French. I don't know if you know what a slide is. Like the stuff that kids slide on. This stuff, it's a toboggan in French. Okay. Can't log in. Corrupted database. Password policy and then the password. Oh wow, okay. Okay, so what we want to do is check this value every time and checks whether it satisfies this constraint. Okay, let's get the puzzle input. Oh boy. And let's create a new file. There you go. And we're gonna take this as well, just for testing. Okay, so let's see. Lines equals read file. And I want input to test. Okay, and what we're gonna have, let me think for a second. So we want to create some kind of constraint and see if it satisfies the constraint. And how would we do that quickly? I mean, I could just loop over the... Okay. So the first thing I'm trying to think how would be a good way to do it, and I'm thinking about storing that in a specific place, storing that in a specific place, and then mapping over the list of pairs that I'm going to create, and checking if that satisfies this constraint. But the first thing I would like to know is whether this satisfies constraint or not. So let's create a data class constraint. And I'm gonna want a so a min, it's gonna be an int, a max, it's gonna be an int, and I'm gonna want a letter, which is gonna be, okay, let's call it a string, but I think we're gonna use something else. Yeah, that's gonna be a val. Okay, so what I want first is we're gonna create a small helper private fun to constraint and password. This is just for just to be able to further process the stuff. So I'm gonna want, it's gonna return a pair of constraint and a string. And it's going to take a string. Oops, I've been writing a lot of Java lately, doesn't help. There you go. Okay, return pair. So cnp dot split, and we're going to split it at that. Well, the second part is easy. That be yeah, that's going to be this. Now, for this, we're going to create a constraint from. Let's see, how does it look like again? It's going to look like this. Yep. So I want to trim, and as usual I'm going as fast and dirty as possible, and we'll see later for a better version. Okay, so that's that. And we're gonna see how, yeah, so I don't want to use, okay, I'll be a bad person, and what I'll do is val constraint equals, so if I split res and the 0 of 0, add the space, and then constraint info, then I'm gonna have 1 and 3 and a, then I can say that my constraint is gonna be on one end we're gonna have constraint info of 0, so the first version dot split with this, with the 0 again, but then we want the second version of it, second part of it, sorry, up for the maximum, and then it's going to be constraint info of 1. That should be fine. What does it look nice? Oh yeah, and I need to int. That's going to be better. That's horrendous code, but that should make it. And let us see now. To constraint and password. And I want to print the first one, and I want to print the second. This is not a 0, this is first. Okay. Let's run that. So we get this 1, 3a. So that works. Ooh, easy. So now if we do var constraints equals lines.map, And then if we use the toConstraint and password method, let's see. Oh, that's a shame. Okay, I would have liked to be able to use it. Well, IntelliJ is going to tell me if I can do better, but I can do it like this. Okay. And well, this is actually constraints and passwords. Okay, so now we have applied the function to all of our inputs. Now the second thing we want is given satisfy constraint. So given a constraint and given a password, I want to return a boolean, right? In the example, 2 passwords are valid. Yeah. So how then am I gonna do that now? I want to avoid a for loop. I could say password dot flat map. Let's see, how does flat map work again? I never know. So yeah, flat map is going to return me a list. Yeah, it's not flat map that I need. It's fold. So I'm going to start. Yeah, I'm going to count the number of letters of the password in the constraint. So I'm going to start initial and then an operation. So I'm going to start at 0 and I'm going to want an operation that takes my accumulator and my char. Oh yeah. Let's see, X. Oops. And that's going to return 1. If I do that, does it work? Oh, how do I do that now? I think I can do it like this. Up. And return 1. I haven't done Kotlin for a while. I just need an example to see how the lambda looks like. Give me an example. Yes. Right, I just want you to give me an example. Where is the example? There's no fold in there. Fold. Yeah, we start with an empty and then, oh yeah, okay, I'm putting parentheses because I've been doing some Elm lately, but we shouldn't have it. Okay. So that's the accumulator and that's P being my letter. So I'm going to say if P is the same as the constraint dot letter, I want ACK plus 1, else ACK. And now I need this from string to char. what's happening. Okay, so now we have val number of letters, and then what we want is we return is that, how does it look like? Is one allowed at least one time and at most one time? So we have then number of letters should be equals or smaller than constraint dot max, and number of letters should be greater or equals than constraint dot min. Let's see, we're gonna print out our example c and p's dot map satisfy constraint x dot first, x dot second, and let's see what it gives. True, false, true. So true, false, true. Yay, we're good. Whoop whoop, that works. So instead of how many passwords are valid? Okay, so instead of map, we want to do, well, we could do fold, but I can do a filter and a sum, all size, because I'm lazy. So in this case, I'm expecting 2. Yay. I'm gonna remove that, confusing. And we're gonna run on the real one. Book. $3.96. Yay. Okay. So now we have part 2. They don't seem to be official Toboggan corporate authentication system. Yeah, okay. Oh, it's the old one, of course. Oh, okay. So essentially we're going to change the is valid satisfied constraints part 2. That's what's going to happen. What we want now is, okay, 2 positions in the password. And we're going to go back to test. We're going to change that to 2. Let's see. So we want, it's actually simpler, isn't it? Exactly one of these positions must contain the given letter. So what we're going to do is we're going to take our string. Let's see. Is 1. That's a boolean. And we're going to say string dot substring. Wait. Password dots. I want the index. And we are going to be at, okay, 1. 1 is 1. So that's going to start at 0. So that's going to be constraint of min. That starts round by 1. Of by 1 errors. So min is going to start at 1. So we're going to do -1. That's going to give us the constraint of the minimal equals constraint dot letter to string. Oops, string. Oh, actually, maybe I have a char and a char. That's actually perfect. No? Char and string. Who's a char? Dot single. No? To char. What? Oh, my letter is okay, to char. Char, not array. Single. Okay. And then we have is2, so we're gonna take the max now, and we're gonna do the same thing. And we're gonna return we want only one of them. One of these positions. But I don't wanna, or, oh, I'm so bad at that stuff. I want exactly one of them. Okay, I'm gonna do it the very bad way. Is one and not is two, or is two and not is one. Let's see. One of them, valid, invalid, invalid. Okay, that looks fine. Let's see now. $428. Yay. That's it. Okay. That was actually pretty bad. Pretty bad code, but we wrote it in a way that was easy to change, so that's nice. Let's see how I can improve that later. Cheers, guys.